Hello friends. So today we are going to solve two questions, and both these questions are from the rotational motion. Okay, 1 second. Okay. So in the first question, it states that a solid cone rolls without slipping on a horizontal table. The cone has a vertex half angle alpha, and the length of its axis from the vertex to the center of the circular base is h, as shown in the figure. Let point P denote the center of the base, and suppose that at the instant shown the speed of point is v relative to the table. Determine the cone's angular velocity vector, magnitude and direction with respect to the lab frame at the instant. So we can just draw the given figure. So we have a cone, and that cone is something like this. And this cone is lying on some kind of base. And we are given that the center of this base is called as P, and this is the vertex. The vertex suppose we call as A, and the line joining this vertex A and the center of the P, its length is given as h, okay, which is indirectly the height of the cone. And the angle is given to us as alpha. And it is said to be rotating in this direction. And it is mentioned that it is rolling without slipping. Okay. And so we can just draw a simple triangle where the vertex is given as A and it is extended to the point P, and let us draw a perpendicular from the point P to the base, to the horizontal path, okay, horizontal base rather, on which it is moving. And this angle is given as alpha, and we have the h is the height. Therefore we can say, let us call this point as P prime. The contact point is our P prime, okay. And the perpendicular base is, let us suppose, the perpendicular which we dropped down, let us call this as Q. So this length, that is our AQ, will be our h cos of alpha. Okay. And we are given that the speed of point P relative to the table is given as u, is given as v. Okay. And okay, so it means if we draw a vertical point. So this h cos alpha will be basically the radius of the circle, okay, in which it is rotating. So this is not actually symmetric, so I'll try to get it. It will be something like this, and similarly the point P will be also moving in the same circle radius. This will be also our h cos of alpha. So we can say that point P moves in a circular path of radius h cos of alpha with at speed v. At speed v, that is mentioned in the question. And so we have already drawn the vertical axis. Okay. So it means that the cone's angular velocity through this vertical axis, suppose that is our omega. Therefore we can write that cone has a angular speed about the vertical and that is our omega, which will be equal to our v divided by h cos of alpha, okay, which is also called as a precision speed. Okay. And in terms of vector, we can write that we have a angular velocity vector let us suppose it is a z-axis, therefore we can write this as our omega k unit vector. Okay. And it is also mentioned that a cone spins about its own axis. So we are given that cone also spins about its own axis, okay. And let us call that as with angular velocity. Okay. So we can call this as a spin rate and denote it as omega s. Okay. So it is moving and we have our omega s. Okay. And let me redraw this cone.